practice.
That's Labor Day.
Alright, if we're talking about quadratics, y'all listen up. Talking about quadratics, we know that it's got something to the second power. What I'm writing right here, this is called standard form of a quadratic. Ax squared plus bx plus c. We'll refer to that all year long. I'll say that parabola or that quadratic's in standard form, that's what it's talking about. There's some things that we can get out of that that'll help us know what our graph of a quadratic is supposed to look like. First off, the a. Okay? The a, what's out in front of your squared, the coefficient of your variable squared. If that a is a positive, which would mean it's bigger than 0 if it's positive, right? The parabola will open up. If that a is a negative, which would mean less than 0, the parabola will open down. Okay? So you can know that right off the bat on whether or not your parabola makes a U or an upside down U. Yeah, there you go, Stevie. Very good. Okay, now we can use that A and B to help us find the vertex. And do you know where the vertex on a parabola is? Do you know what I'm talking about when I say vertex on a parabola? Good, Trevor. It'd be that point right in the center on these. Okay? Even though I draw them messy, we know that a parabola is symmetrical. It's got an axis of symmetry going down the middle of it, right? You can fold it, right? The vertex would lie on that axis of symmetry. And we can use that A, B, and C stuff to help us start finding it. So find the axis of symmetry. X is equal to the opposite of B divided by 2A. And that'll always tell you that axis of symmetry. So then if you're trying to find the vertex, after you get this, X equals something, you just plug it back in for the X and solve for Y to finish out the vertex. And we're going to do it. We're going to talk about it. It's not really all that difficult. So don't get bogged down. Let's see if there's anything else we can get right now before we move on. I think that'll be enough. I think we just need to try one out of that. Alright, let's say I have f of x, going to do one here, is equal to 3x squared minus 6x plus 1. That's in standard form because it's an ax squared, a bx, a c. We got some number in the a spot, some number in the b spot, and some number in the c spot. So that's in standard form. The directions here ask us to graph it, to label the vertex and the axis of symmetry. So I want to find the vertex and the axis of symmetry first before I worry about a graph. To find the axis of symmetry, we have to know what our b and our a are. So tell me what is, let's just label all of them. What's our a in this function? 3, our b?
And that's 1.
No? You said right. -6. Good. Y'all were right the first time. And then there's your 1 is in the c, right? Okay. So if I'm trying to find the axis of symmetry, I'm going to say x equals an axis of symmetry on a normal parabola. And I say normal like these two up here, an upside down one or a normal one. Those are normal parabolas. The axis of symmetry will always be x equals. The reason I'm telling you that, not today, but later, we will get to sideways parabolas. Okay? Their axis of symmetry will not be x equals. It'll be y equals. But we're not there today, so forget it for today. Alright, x equals always negative. Okay, so I've got my blanks ready to fill in. B on the top, and 2 times a on bottom. Okay. Alright, so I know that my axis of symmetry already is going to be a positive number. It's going to be on the positive side. Everybody with me on that? Because I got a negative divided by a negative, which is a positive. 2 times 3 is 6. What's 6 over 6? 1. So x equals 1 is my axis of symmetry.
Wait, why is there a negative in front of a negative?
So, yeah.
I was going to ask you how to get rid of that.
Yep. Y'all are thinking good. Now, I want to draw, if I can find a marker real fast. And y'all see over here if I draw just something. So that dotted line that I drew there will be the center. It'll be the line of symmetry for our parabola, right? I went over to x equals 1, and that dotted line will be where my parabola can fold. Okay, that's what we just found on that. Okay, if I want to find where the vertex is on this, now I'm going to take my 1 and I'm going to plug it back in on the x's and solve.
That's where it crosses the line.
No, that has to do with the c. We'll get to that in just a second. Connor's ahead of us. All right, let's plug the 1 in for the x's and see where our vertex is. So we'll have y is 3 times 1 squared minus 6 times 1 plus 1.
3 times 1 is 3. No, negative. You don't have to square that 3?
We squared the 1.
Oh, okay.
That's a good question. Getting everybody straight on that. So that gets us negative 3, and the negative 3 plus 1 is negative 2. Right? So if I pair that, make an ordered pair, I got the negative 2 when I plugged the 1 in. So 1, negative 2 is our vertex. So I can go over here to our picture, and I went 1, negative 2, and there's the vertex.
Well, we get closer.
I know it. Now, is this parabola from that point going to be here or here? Top or bottom?
Hang on. What?
Okay, what's our A?
Oh, wait.
What's the A?
3.
3, which is a positive number. So it's going to open up. So I got a pretty good idea of how to draw that already, but I need to just get another point on it. Chloe,
Does it always have to go through the Y? No, wait. Which one's the Y?
this one.
Oh, yeah. Does it always have to go through the X?
No, it could be sitting up here and be like that. That's a good question. All right, so I want to talk about the point that Connor brought up about where it crosses the y-axis, and we get that.
So this one go down?
No, our A is 3, which is bigger than 1, so it's going to go up.
Oh, okay.
The vertex will be at the bottom. And we got more to add on to that here in just a second.
I think the vertex is
Gotcha, gotcha. All right, the C in this, we were talking about a y-intercept. The C in your standard form is going to tell you your y-intercept comes from 0, C. Okay, so what's our C? We've already labeled it. 1, so our graph's going to cross the y-axis at 0, 1. Now this is pretty cool, if I can run all around the room. If I go over 0 and up 1, my parabola's got to hit that point, right? If I am right there on the left side of my axis of symmetry, don't I have to be equidistant on the other side? So I don't even have to plug another point in. I can just do some elementary tot school counting. This is 1 unit away from my axis of symmetry. So I'm going to go 1 unit away on the other side. Right? We've got a parabola now. Not too difficult. Okay? Now, does this parabola, some new words, probably need to write them over there so the video can see them. That'd be a smart thing to do. Does this new parabola have a minimum or a maximum value? I've heard both, so I want you to think about it. Look at your picture over there on your paper and think about it. If you tell me it has a maximum, that means you can reach the top of it, right? Can I reach the top of that parabola I've got drawn over there?
No, the lines go forever.
Good. It keeps going on up forever, so I can't reach the top of it. If that were a mountain, I would never stop climbing, right? But it does have a minimum. I can reach the bottom. So that parabola over there would have a minimum.
And
No. It would have a minimum of what? How low did it go here? -2. We got that from the vertex. So it has a minimum of -2. Look at what your vertex was. It will always be the y of the vertex. Your max or your min will always be the y of the vertex. Okay? Alright, we can tell we can tell something else about this. Increasing and decreasing. This is all words that you could see. DC, decreasing. Alright. I hit my min there at the vertex. So if I'm looking for a section where this graph increases. Increase means I'm going up, right? So you read a graph just like you read a book from left to right. So it goes up where? Oh, that's a bad question. Let's read the graph. Rewind. Let's read the graph left to right. So we're starting over here. The graph goes all the way up way over here, right? So as I'm reading it left to right, and I finally touch it right here, I would be coming down to the vertex, right? So it would decrease from -infinity to 1. Okay, what in the heck is that talking about? Infinity forever, and I'm on the left side, so it's negative. Okay? And it keeps going down, it keeps going down, it keeps going down, it keeps going down, until it gets to where x is equal to 1. Right? But what happens when it hits x equals 1? Woo! Takes off up the hill, doesn't it? So up
It increases.
would be increasing. Go, Trevor, from 1 to positive infinity. Okay? Now, no, it's not. It's just a new thought for you. Think about if we had upside down parabola.
It would be the opposite.
Right. It would increase from -infinity to whatever. And then it would decrease from whatever to positive infinity. So Chloe's right, it would just be the opposite of what we had over there.
So we are positive and negative. And it's negative, negative, go from negative to a negative, or from positive to a negative.
I don't understand. Say that again.
So this one is positive, positive.
Okay, I got you now. You're talking about the order of here, but we're just talking about left and right. So we're not worried about left, right, and down. We're only worried about left and right. So over here, we're on the negative side. Over here, we're on the positive side. You're putting it all in the order of pair, up, down, and left and right. But we're not. We're just moving left and right on the graph like you read a book. Is that kind of clear? Not really. So on your number line.
So if it's upside down, because I got the one where it's up, how would it be building?
Okay, so
So it's up towards.
it's going to, it's forever to the left, right? This is going to keep getting wider and wider and wider forever to the left. So that's headed towards -infinity. This is forever to the right, wider and wider to the right. So that's headed towards positive infinity. So this would increase from -infinity to whatever is right there, because it's going up the hill. And it would decrease, this is 2, from 2 to infinity, because it's going down. So we would say increase.
I thought you said that was negative.
Oh, over there?
Yeah.
Oh, I didn't mean to, I did. And then decrease.
Does anyone sit over there ever?
Yeah,
What's the period?
fifth and first.
How do you know that?
My brother. And fifth is my biggest place.
Someone told me the other day, you know Jeremy, somebody they're like, they said, I don't know what your last name was, but somewhere, well, they said your last name.
Just
I'm
blue.
like, wait, I think there's one that's been in. Yeah, oh my gosh, yes, I love her. She's like,
You're
yeah,
most
well,
definitely.
her twin. I was like, wait, I don't know her. Because I didn't know her. Because I, like,
Alright, this says x equals 2 times x minus 2 squared plus 5. Okay, we are, and some of y'all will remember from Algebra 1 because y'all did a pretty good job remembering that stuff. We are going to get to different forms of quadratics. Remember that first one that I wrote was called standard form. We're going to get to some that's called intercept form. We might get to intercept form today. And then we're also going to get to something that's called vertex form. Okay, this one is actually already in vertex form, but we're pretending like you don't know that yet. Okay, so we're going to go ahead and make this be in standard form. And this is going to take some Algebra 1 skills to put this in standard form. Okay, standard form, ax squared plus bx plus c's got all multiplied out. This is not multiplied out.
Wait, it's 2b?
No, because we're not in standard form yet. That's what I'm saying right now.
Sorry, I was
That's okay.
2 times that.
Not yet. That is something I'm going to have to do, what Trevor's talking about. There's a 2 that's going to have to be distributed. But before I distribute it, I need to take care of that parentheses being squared. Good. I'm going to multiply both of those parentheses. This does not mean, and this is Algebra 1 stuff here, this does not mean that we just square both of those. Okay? It means we take that whole quantity twice. Okay, remember that? Now, some people have different methods for how to multiply these. You are just distributing everything. I use what some people call the FOIL method. You ever heard of that before? First outside, inner last. That's the way I do it, but I'm going to say x times x on my first. Right? Come on. Outer, that means the outside edges, x times -2. Nothing new here, but it's been a while. Inner, the middle 2, -2 times x. And then last, the last one in both of them, -2 times -2. Okay, now 95% of the time when you multiply two binomials, which is what you just did, your middle terms can combine. You got like terms there, right? So I've got x squared minus 4x plus 4. Okay, that's closer to standard form. We're on the right road. Now I'm to what Trevor was talking about. This came from that, so there's still a 2 that needs to be distributed to all of these, right? So let's distribute that 2 there. Gets me 2x squared minus 8x plus 8. Okay, good, Connor. I've taken care of everything to here. But now Connor reminded us there's a plus 5. Well, that's easy. Just combines on the end with that like term, 8 and 5. So we've got f of x equals 2x squared minus 8x plus 13. We had to do all that preliminary work to get it to standard form. Okay? So now, this is what Chloe was ready for. What's our A? 2. What's our B? -8. And our C? 13. So to start finding the info on this graph, you're always going to start with that formula for axis of symmetry. X equals negative B over 2A. Everybody see how I plugged all that in? Now we got a negative divided by a negative, so that is a positive. 8 divided by 4. So we get an axis of symmetry at 2. Y'all got that? Agree?
Awesome.
Okay, now what do I do to find the other part of the vertex? Because I know the vertex has to go through that 2. So what do I do to find the other part of the vertex? Close. Good. Plug the 2 in for all the x's and solve. Okay, so we're going to say, oops, went too far. There we go. 2 times 2 squared minus 8 times 2 plus 13. Okay, that squared's only on that second 2, so 2 squared is 4, and 4 times 2 is 8. 8 times 2 is 16. 8 minus 16 is -8. And -8 plus 13 is 5. So we have a vertex at 2, 5. So we've got a vertex, we've got an axis of symmetry. Ready to look at it on a graph?
Let's do it.
That's what I'm talking about. Well, that wasn't very good. I wanted it to be down here and it went up there. Well, that's just back to the dry erase. Do it over here in the front one this time. Alright, we got an axis of symmetry at 2. A vertex is at 2, 5. Right? Should have drawn that different. Is this going to open up or down? What's our A? A is a positive 2, so it's going to open up. That's why I was saying I should have drawn it different, because I'm not giving myself a lot of room up there. Even better when you look at your y-intercept. What was our C on this one? 13. So it's going to have a y-intercept at 0, 13.
Put a dot on it,
Right above here.
yeah.
Okay. I like that, Stephen. He's technical like me. That would be over 0 and up 13. That's what we're saying that is. Okay, now, if we continued our axis of symmetry up, it's 2 away on the left. So we would go 2 away on the right, and it would be at the same height, right? Get something looking like that. That's not bad, considering I didn't plan that very well. Increasing and decreasing stuff is going to be the same since it's going opening up. The only thing that will change is it won't be a 1. How many over is that? 2. So it would decrease from negative infinity to 2, right? And then increase from 2 to infinity.
Under the following students in the high school office: Mason Massey, James Webb, Brock Trammell, Avery Womack, Cass Badness, Winna Dyer, Jarrett Prince, and Logan Hubbard.
Wait, it'll decrease negative infinity to 2. Is that what you said? And then increase infinity.
Correct.
My infinity signs are in this.
Negative infinity to 2 and 2 to infinity. Yes. Yes, you got it. Which would this be? Can you ever reach the top of it? So it would have to be a minimum. Very good. The 5, it's the y, so the minimum value would be 5. Y'all got what Stephen reminded us on that one? This would have a minimum value of 5, because that's where its low point was, right? So remember, if it opens up, it has a min. If it opens down, it has a max. Okay?
Okay. One to the 10.
Alright, want to give you one to try by yourself. Close it out here. You ready? We go already in standard form. I'll be nice to you. Y equals x squared plus 2x plus 1. I want the axis of symmetry.
Oh, it's already in the.
I was nice to you. I said that for you.
Oh,
I want the
sorry.
vertex. I want to know if it's a min or a max, and what is its min or max.
Is this our homework?
No, this is a 6-minute get it done. I want to know where it increases and decreases. Okay, so all of that, go.
Would A be 1.
Yes, yes, good job.
I ain't fine, that's just symmetry.
Yep.
Would you leave it in, what do you call it, the line of symmetry, would it be best to leave it as a fraction?
You don't get a fraction on it.
We-
Negative b over 2a.
That's where I messed up. I messed it up.
Because your a is 1, so 2 times 1 is 2. So you look at
I'll stay right there.
Oh,
so it's 1. I don't think the 6 is right, is it?
Negative 20 squared.
And then minus 2.
Minus.
Linear 1 negative when you plug it in? Oh, it's
We got to put
your
that
axis
one in.
symmetry
I
is
would say negative,
Is
I
it-
would say it's
you
supposed
do
to be
negative 2
one.
divided by 2? It's negative 1.
Yeah.
So that's what you're supposed to do. Wait, what makes the first two negative? Because it's positive and the equation is the opposite?
Yes.
Okay.
You don't have to leave it.
Yeah, it's got a vertex. Every parabola has a vertex. 0 is an okay number, Stephen.
Oh,
Hey, is this right?
I need the following students to the high school office. Leighton Withers, Taylor Dixon, Chloe Dixon, Braden Carmen, Grace Bryant, Kinsey Bryant, Kylie Moore, and Raven Newton. Thank you.
Plus negative 1. And then plus 1 would be 0.
Is your line of symmetry your X?
Yes.
So we got-
So, okay, why is this
we
one?
got-
What the one?
What else did you say we had to find?
Oh, yeah.
Do we have the next question or is this one?
This is
Oh my goodness.
all right. I've got all mine. So check and see if I got it right or if you got it right. Let me know. Let me know what's going on. Any questions on any of that?
so your vertex will be your minimum and maximum?
The y of the vertex will always be your min or your max. Yes, sir.
Oh.
Any other questions on that?
Oh my god.
Everybody seeing where you messed up or didn't?
That's it.
I'm not bad.